a website and then type in the name of the website that's listed. Right there, it will be on the piece of paper or announced in class will be a username, and this particular one is 10, and the password is 1010. You will get to a website that looks like this, and obviously this is not this year's, it's last semester's, and I'm going to do a right-click Save As. Now, you've been, where's my right-click? I missed it. Save As. Okay. Now, you can put it wherever you want. I'm going to put it on the desktop so I can find it. Okay. I'm done with this page, by the way, although the directions are to unzip, open, build, start, run, make sure you got 0. That'll be your directions as well. Okay, so I'm done with the website, actually. And this is where it went. So the first step is you must extract it. Again, extract it someplace you can find it. Again, it's on the desktop. I'm going to launch. Notice that my Windows, I have file extensions on. This way, when I go to upload it, I'll know which files are which. Okay, so this should look like this, but obviously yours is going to be different. You can read the exam paper. You can read the question. Put your name here so that I know who you are. Right, so I don't have to take off points for not putting your name. It helps me unsort if for some reason we make a huge mess. All right. Again, what it says to do is to build, run. Okay, I'm going to shut the dinger off here. Shut the dinger off. Run, and then down here in the UART window, I should have gotten a 0. I did. Which is fine. I haven't got the exam yet. At this point, we're going to start your 60 minutes of programming. Okay? If you take more than a minute to do what I just did, you're starting late. Okay? So you'll get about a minute, 2 minutes maybe, for you to get to this spot where you got a 0. And then we're going to launch the clock at whatever, 12:35, and that's when we'll end at 1:35. Okay, see how I'm going to do that? So, and then the last 10 minutes will be used to unload, to check your stuff at the end. Okay, so now I'm done with that. Okay, so now the job is to program. Now, most of these exams, I can do them in any order. If you read the directions, it'll tell you the C is different than assembly. And so if you want to maximize points, you can decide which you're better at, C or assembly. Start with the one you're better at. Don't spend the whole time with something you can't do, okay? So I'm happy to be good at everything, so I'm going to start at the beginning, okay? Make sure you understand the parameters. And so here in this first example, is it null? It basically will pass in a test case, which is a structure which has 2 parts, well, 3 parts. It has the name, the score, and the group number. Okay, so the first guy is Johnny, and the question is if I pass in one of these things, is that null? No, Johnny's not null, and so I'm going to return a 0. When I pass in the second one, this string will be null, and I'll return a 1. So let's get going. So what is pointing to the structure is the variable. And so if I do it, because it's a string, I'm going to read it as unsigned 8 bits. Okay, and so if I do a R1 bracket R0, I am going to get the J. Now, this is me programming. If I think I can type 100 lines of code in and get the right answer, I will. You may not be there. And so what I'm going to do is hit a breakpoint right here. I typed 1 line of code. I'm really proud of myself. I'm expecting a J in R1. Okay? And so debugging is the process of comparing what it is I expected with what it is I got. Okay? So I'm going to run to that breakpoint and look and see. Well, I got to notice that if I want to see my parameter, right, my parameter is an R0. You see the number there is 2,000, 4 zeros, 190. And so if I go down the memory window and write 0x2000, 190, present this as either hex or characters or whatever. I must have typed it wrong. More zeros. Yeah, more zeros. There we go. There's my letter J, 4A. Huh? And so when I execute this next instruction, I'm expecting a 4A in R1. Okay, so I got what I wanted, so obviously I don't need to run anymore. Okay? And now this is a classic if-then-else thing, so I will compare it, R1 with a 0. 0 means no, and if it's equal to a 0, after a compare instruction, what instructions can I execute after a compare? Equals, not equals, high, low, greater than, less than, high, same. Those 6 to 8 instructions can be executed after a null. Okay, so if it's equal to 0, that means it's a null. If it's not equal to 0, that means it's not a null, and I will move my return parameter R0 with a 0 for proper. Okay, and then I like to have a single return statement. And so rather than doing a BXLR, I will branch to the end. And then right here, I have is null. Move R0. The return parameter is obviously in R0. That's ARM architecture procedure call standard. Where was I? Equal to 1. And then I need to make this compile, so I need no, done. Now, do not hit the go button. Okay? Now, I know this works, and so I would get points. But let's just leave the breakpoint there. Let's do the same thing. Okay? I'm going to run, and now I'm going to go in my mind, what is it I expect, and what is it I got? Okay, so again, I expected this to, I get to this if statement, and now, do I expect it to branch or not? Well, it's not null, so I don't expect it to branch. And it didn't. Okay, and so I return to 1. Let's run it again. Okay, now when I execute this, to see my parameter, I go back over here and I see I have a new parameter that's 1B0. Okay, so I'll change this to a B. And now there's my string with the 0 sitting right there. Okay, with me? So now when I do execute this one line, and I do expect this to branch, and it did branch. Okay, so now I'm pretty much happy that I'm going to get it right. So I hit the get rid of the breakpoint. I do finish running, and I see that I got points for the first one. Okay, 1 down, 3 to go. All right. All right, let's get a little bit more fun here. Okay, so this one's a little bit harder. This one's a little bit harder because you got to read the directions. Don't imply, don't guess. Don't guess what it is I expect. Don't, because that's what I did last time. He did it on the leather exams. No, read it. It's an array of students. In other words, an array of structs and an index into it. So, for example, in this test case here, the input is an array of length 2, okay? And then I passed in an index, okay, of 1. So it's going to add, the index was passed in as a 1, so it's going to add the score, the 80 plus 70, and return the 80 plus 70, 150 as a result. Okay? You see that? And so one of the things I can do is say, hey, John, what's the first element? Okay, so let's try to get the first element. So if I were to, I go up here and I see the type, right? The type of this is unsigned 32 bits. So if I do a LDR into some register that I don't want to mess up, R2 say, doesn't have anything in it, no, R2, sorry, type it, R2, bracket, should I capitalize the R? Whatever's fastest for you to type, okay? Shift keys for you losers, okay. Pound 8, okay? Where did I get the pound 8? I can see that all the strings, regardless of their size, are 8 bits wide. And so if R0 is pointing here, R0 plus 8 is pointing to the 80. Okay, so I expect there to be an 80 in R2. You with me? So let's see what happens. Okay, build, run. Again, don't run too much until you figure out what's going on. I'll go back over here to my, I gotta run to my breakpoint. Oops, missed it. Oh yeah, there we go. Breakpoint. No. Where's my breakpoint? Didn't get there. Oh, I forgot the breakpoint. LDR R2. Okay, I obviously I made a mistake. It didn't compile. Hold on. LDR. Build. There we go. Run. There we go. Okay. So R0 is 190. I could go back over here and put the 190 back in. Okay. There is my, right there is my 80. That's in hex. There's my 80. And so when I'm done, I'm expecting R0 to equal that, R2 to equal that. I execute 1, and I see that it is there. Okay. All right. So in order to solve this problem, I'm going to need some local variables. I'm going to need some variables. This is assembly language, so you can see I'm going to need one variable, which is the sum. So pick a register, move R3, pound 0. That'll be my sum. I'm going to need an index. So what register do I use next? 12, why? I don't have to save it. This is going to be my index, which is going to go from 0 to it. Look at this. Does it ever not look at any? No. Even the indices here, the test cases, are all non-zero. So even if it were 0, it would look at the first one. And so this is a do while. I look at the structure of this and I think do while, because it will always execute at least once. Okay? And so I need a place to go back to. And so now I'm going to fetch. Okay, let's go get this. Here's my sum. I need that one. X. I need that. Okay. So I just fetched it. This is the score of this student. I add it to my sum, which was R3. Now, I like to go all 3 of these on add, so you're not stupid like that. See, I made a mistake. R3, R2. Okay. And then I'm going to increment my counter, which is R12. And I'm going to compare my counter with my index, which was in R1, right? So I'm comparing the local index I. Let's call this I. Go back and call this I. And I'll call the thing that I passed in. I'm going to call the thing I passed in index. Okay? So I'm compare I. Is it less than or equal to index? All right. So if index is, so for example, if index is equal to a 3, do you count the 0th, the second, the third, the 0, 1, 2, and 3? The answer is yes. So this is a greater than or equal to. Are these things signed or unsigned? Is the index signed or unsigned? Unsigned. Branch high same. Now, in this particular case, it would have worked either way. All right. Okay, so this is going to loop through. There's my do and there's my while. And my answer here was in R3, so I'm going to move it into my results. All right. All right. Again, let's go through the first one. Leave the breakpoint there. Right, so I'm going to get my breakpoint. I'm going to step over. What do I expect to... Whoa, run. Run to my breakpoint. Step over. Now, you can't step out of a reset because my program's thousands of lines long. Okay. So what do I expect to be in R2? I made a mistake, by the way, in case you're ahead of me. Okay. What do I expect to be in R2? An 80, which is a hex 50. Okay. And so R3 became an 80. The index got incremented. I compared it. Do I expect it to go back? Yes, because index was 1. And that meant I'm going to do for the 0th and the 1th time. And so now, what do you expect in R2? Look at the test case. Right? Look at the test case. I expect a 70. Right? The first one and the second one. What do I got in R2 when I execute 1? I got another 50 again. I got two 80s. I expected the answer to be 150 and it's 160. Okay? See my mistake? So don't hit the go button, fix it. The problem is I need to increment the pointer to get to the next structure, right? So I go back up here and I go, hey, John, how big is one of these structures? How many bytes in a structure? How many bytes in the name? Always 8. How many bytes in this? 4. How many bytes in this? 4. That's 16 total bytes per structure. And so I needed to, in my loop here, I needed to add to the pointer a 16, I mean. This is going to the next entry. All right. All right, let's try it again. See how we do. Again, I put my breakpoint there, I hit the go button, and now I'm going to go through the loop twice again, right? That's the time I did before. And now, here in R2 is not the 80, but the 70. And so when I add it, I now R3 is not equal to 160, but 150, right? And I can go down to the bottom and see that it does return. Uh-oh. Oopsies. All right, I made a mistake. Compare, branch high, same. The 12 is now 2. Okay, so I went through 1 too many times. I expected to go through the loop twice, and it went through the loop 3 times. That's not good, so I'm going to do a high. No, it's the other way. Oh, it's the other way around. Low same. There we go. Low same. Low same. There we go. This guy is lower than that guy, or equal to. There we go. So I would have had an infinite loop. I expected it to go through the loop twice. It went through the loop 3 times. I abandoned ship and went to fix my bug. Okay, there's the first time through, there's the second time through, and then it quit R0 is now equal to 150. Okay, so now I'm emboldened. I don't know. I can run it one more. Run the second test case. Right? I can at least figure out the second test case, how many times through, and that is the index is equal to 3, so I'm expecting to go through 4 times. And so I will see that it goes through the loop. That's the first time, there's the second time, there's the third time, there's the fourth time, and it stops going through. Okay? So now I'll get rid of the breakpoint and see what happens. Again, don't look at the UART window unless you're some kind of superstar. Okay? Don't debug by looking at the window. Look at what's expected versus, okay, half done. Ready to score. All right, 50. All right, let's go on. Questions on the assembly? Yeah, questions.
So you can add to R0 instead of making the offset, right?
I could have added to R0 once and then added 16 each time. Yeah. So the answer is I could have left this as a 0 and then up here add to it once. I add 16 every time, but I add the 8 once. This would have worked. Yeah, question?
How did you get to the first score in the first phase? And how do you know that?
I added 8 to it.
But doesn't the word Johnny take?
No, read the directions. All student records are the same length, irrespective of how long their names are. Okay. And look at the test cases. When Johnny was 4 characters long, what did it give you? 0000 to pad it out. That's what the C did up here as well. Okay? So if the string is less than 7 characters, it'll pad them out with crap.
I see. All right.
Yeah, good. Another question? That was good. Yeah, question?
Okay, I'm kind of confused on the purpose of R1 here.
Okay, just the point is, there in this particular case, he said, "What's the purpose?" Just to make it hard. Okay, in this particular case, how many people in the group? How many people in the group? 5. I'm going to sum up the first 4. That's the purpose of the index. It's a subsum of the first 4. Since index was 3, it's going to do a subsum of the first 4 devices. I don't know. Just so you don't have to check for, just so that you don't actually have to call is null. It actually made this problem simpler than if I made you search to the end, and then you couldn't figure out where the end is. I'm trying to give you points. I made it easier, but weird. I didn't sum the whole class. I just summed the first 4 students. To make the question, he said, why did I sum only the first 4? He said, why do I sum only the first 4? You're overthinking it. You don't care. I asked you to do it. Just please do it. And actually, the reason why I made you sum the first 4 is to make the first question distinct from the second question, distinct from the first question. Okay? So the second question isn't dependent on your being able to answer the first question. That's why I did it. Yeah, question?
So you added 16 to skip over the name and...
Yeah, to go to the next record.
All right.
Yeah, because I knew how big the record was. Good. More questions on assembly? Yeah, go.
This question, we also going to have to figure out where the inputs are. Like, do we just assume it's going to be...
Okay, no, he said, do I have to figure out where they are? Yes, you do. How did I figure it out? How did I figure out where the inputs were? Inputs. How did I figure out where the inputs were? R0, R1. ARM Architecture Procedure Call Standard. Okay, and then looked in R0, and I took that address and I put it in the memory window. Yeah, you're supposed to figure out where the inputs are, but it is ARM Architecture Procedure Call Standard. That was a good question, actually. Yes. You have to see your inputs. It's not mad. You can't guess. Your guess is going to be poor. All right, good question. More on assembly? All right, more assembly. Okay, so the question is, why is it 16? I'm going to answer it two ways. First is I'm going to count it. Okay? This is a record. The question is, why is it 16? This is one record. You with me? This is one student type. Right? This is the second student type. This is the third student type. Okay? All right, so how many bytes is this line? Count them, right? JONY0000. That is 8. Okay, 8. What does DCD mean? 32 bits. How many bytes is that? 4. All right, that's 8 plus 4. I'm up to 12, right? There's 2 of them. Oh, yeah, you forgot. Don't forget the second one. There's 2 of them. That got me to 16. Are you with me? I could have done the same thing if you're very good at C, right? Let's go up to this. And if I asked you, if I gave you this and said, how big is the record? How many bytes are characters each? How many bytes is a character? 1. And how many characters do I got? 8. Even if the string is shorter, I still have 8 bytes. Okay, what is a uint32? 4 bytes. That I'm up to 12. What's another uint? See? Yeah. Good. That was a great question. Kids got stuck there with that. They don't get to the 16. They can't get to the next one. Yeah, absolutely. Assembly language questions? You can ask questions when I get to the end.
So we always add bytes?
Address, she said, do we always add bytes? You always know that addresses in memory point to 8 bits. If I want to go to the next location, you got to tell me how. You got to have how wide it is. 16 bits, I add 2. 32 bits, I add 4. This wiki structure, I add 16. Yeah, but the memory is byte addressable. All right, it's C time. Now, the C, you might want to look at your picture on the printout because it sort of helps you look at it. But let's begin with understanding the test cases. What is this mean? Okay, if I give you this parameter, what am I passing to you? An array of structs. I am passing to you not 1, not 2, but a whole bunch of structs, which are an array. If you looked at R0, what's in R0 here? A pointer to the array of structs. Okay? And so if I look at my test case here, how many students are in this class? A whole bunch. 1, 2, don't forget Susanna. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So my loop is going to go through 19 times. How do I know when I'm at the end? I got to know. Okay, now I got to know. So if you think of this, is it possible that there are no students in the class? Yeah, read the fine print. Return a 0 if the student array is empty. This means it's not a do-while loop, it's a while loop. So let me do what I did for the other one. Let me get one thing. One thing, okay? What if I wanted the name? Okay, here's another thing. I am, because I am going to want to debug this, I'm going to create my variables here. All right. Okay, it's care. Okay, this will be I. I'll get to that in a minute. Care letter. All right. I want to fetch the first letter of the first student. Okay, and so if I want to get the first letter, again, don't be a hero here. I want the first letter of the first student. Which is the first student? Bracket 0. Where's the name? Name. Where's the first letter of the name? Bracket 0. All right. what am I going to get when I stick a breakpoint here? What am I going to get in letter? The capital J. What do I get in the letter? Well, we'll have to see. We'll have to see. Step over. Now you notice that if this were a local variable, it would discard the entire line because you wrote to the local variable and never read it. And so because it's global, it actually executed. So one of the reasons to make letter global is so that it actually generates code that I can debug. Okay, so, and now I can take my letter and put it where? Put the letter in the watch window, okay? And I can even make it ASCII if you want. I guess, I don't know, whatever. Let me just run it and see, step over. There we go, J. You see it? J. I'm emboldened that I am going to be able to get the letter. Okay, so let me do the outer loop first. Okay, let me look at all of the guys. Okay, and again, I'm going to set I equal to 0. That's going to be my index into the class, into the group, into the stuff. And then I am going to look at while, and I don't need letter anymore. Okay. What does it mean to be empty? If this is if this is one of two things, it's either empty or not empty.
No.
No, right? So if this is, and what number is the null? Okay, so if it's not equal to 0, what does that mean? It's not null, which means I got something. So let me increase I. What do you expect I to be the first time through here? At the breakpoint, what do you expect I to be? All right, fine. Let's run it and see.
Don't we have to change student 0 to student?
Oh yeah, fine. Yeah, you're so sweet. Can I leave my? He's just send him to the back of the room. The kid's already figured out my mistake. Yeah. Okay, fine. Let me just go ahead and show you something nasty. Okay. Are you with me? I have a nasty bug, and you will have nasty bugs too. All right. So what happens when I get to the breakpoint? Oops, let me get rid of this one. What happens when I get to the breakpoint? Oh, I'm going out for coffee.
We're always gonna loop. We're never gonna get out.
Right? I go to the window and I go, hey John, your grader is broken. No, grader's not broken. You're broken. I stop. Look at what I is. I put I in here, right? This is why you made it a global. Look at what I is. Like some sort of monster number. All right. So yeah, people realize this should have been I. What about this one? What should I put there? 0 because I still want the first letter. All right, fine. Back. Stop. Build. Yeah. Thank you for. I would say I did that on purpose, but actually I make more mistakes than you can imagine. But I get pretty good at debugging. All right, so you noticed, again, one of the things you can, now I is going to be equal to, yeah, let's make it, right? There were 19 students in that thing. There's my 19. With me? All right, now let's look at the question was asked in the assembly language, whose job is it to figure out what the inputs are? And the answer is yours. Let's look at the inputs, okay? And so I put the breakpoint back here, okay? Reset, right? Reset, run, okay? And now if I go here, can you see what number it gave me? 2,000, 6 zeros and an 8. Okay? Okay, so this is a structure that's weird and wacky. Let's look at it. You did lab 5. Okay? Okay? If I wanted to observe this wackiness, what are the things I'm interested in? I'm interested in these uints. Okay? And so let's make this unsigned. Let's make this unsigned long. Okay? And now it's still in hex. Let's get rid of the hex, make it decimal. Okay? And so now, what do you think these two are? This guy and that guy. That's the name. What's the 70? That's the score. What's the 123? Well, look at it. What's the 123? The group number. Okay? So there's Johnny. Where's Joel? Right? There's Johnny. There's somebody else. There's Joel right there. There's Joel's score. Let's look at Kai. Where's Kai? There's Kai. There's Kai, score 80. Down there, that's Joe. His score is 80. What's Mahesh's score? Where's Mahesh? Where are you, Mahesh? You were off in the bushes somewhere. Okay, somebody scores 75. Yeah, that could be Mahesh. Where's Ben? Well, Ben's not on my list. Okay? All right, so it's your job to figure out where stuff is. Now, sometimes you get lucky. Okay? Sometimes you can get lucky and look at the first guy. Okay? So there's the first one. But you can't see the rest of them. Okay? All right, so, okay, time to write code. Okay. So again, if the group number is 123, let's go ahead and fetch the group number out of here. Okay, G. All right, so I'm going to fetch the group number. G equals students bracket I bracket dot GID. Okay, that's the group number of said student. Now, if the group number matches, all right, if the group number is equal to the parameter GRPID, that means this student is one of the interesting ones. Again, I'm calculating the average, so I need a sum. Oh no, where am I? Need a sum. Students bracket I bracket dot score. Oops, too many brackets. Bracket I bracket dot score plus sum plus. All right. Even if there's one entry in the if statement, I use braces because I might want to add. Why do I have a bug? What's this about? I haven't what? I haven't even defined it. So again, it should be local. I'm going to make it global. I'm going to need to initialize it. Equal to 0. Now I'm close. All right. So what's my return parameter? Nope. That's the average, man. How many? I got to count them up. Oh, crap. I got to count them up. Count. All right. Count. Be careful. Global variables are initialized once, which means if you don't initialize them here, it'll run on the first test case, but not the second one. Can count ever be 0? Yeah. So what do I do if count is equal to 0? Return to 0. I don't want to divide by 0. All right. Now, in this particular case, I'm actually going to debug the second one first. Why am I going to debug the second one first? Well, no, I don't know. Maybe not. Because it's 5. It doesn't matter. I can do them either way. Doesn't matter. Does it make sense to do this? Did I just make my code run slower? Yeah. But why did I do that? I can see the debug. So again, I'm going to move my breakpoint here. And what sequences of S's should I be seeing? What sequence of S's? 70, 70, 80, 80, 75. That's the sequence of S's I should get, because they're all the ones with 123. All right? Put my breakpoint there, okay, and build, run, go. I got to put S down here. You notice how I can take my S and I can do a right click, add S to watch one. I'll change S to be not hex. All right, run. Okay, why is S not 70? Well, I got the stupid grade point. I need to get rid of that one. Run. All right, S is 70. 70. You can also see I going from whatever to, right? S is 80. I is 6. I could have put my count in there. Run 80. Oops, run 75. And now it's going to quit. Eventually. There it is. And there's my answer. All right. I'm emboldened to run this thing. And 75. Questions on that one? Now, sometimes I give you all the test cases, sometimes I don't. Question?
What were the advantages of using global variables? Why do we just not?
Okay, because the question is a wonderful question. Thank you for asking. Why do I use globals? Because when you go to 312, I want your professor to yell at you. No, that's not the reason. They should have all been local. If they're global, they're easy to debug because they always exist. They always exist, and I can always see them, and I can put them in the watch window. Now, if you're lucky, they'll show up in the return stack. But as the local variable goes out of scope, it's gone, and you can't see it. If you add a local variable you don't actually use, it won't even show up at all. Okay, that's why I added them as globals. All right, let's do another one. Okay, so this one is a little bit harder. I need to search the database and find all the groups. Okay. So I give you, this is a trick question. Is this parameter an input or an output? No, it's a trick question. It has to be an input. Why? No, it has to be an input. Because it's a const. You can't write to it. This parameter is read only. What about this one? Now, just by looking at it, you can't tell whether it's an input or output. But if you read the directions, that's actually an output parameter. That's a return values. It's an array that's initially empty that you're going to populate. Right? It's an input and an output. Or technically, it's just an output. Because the thing is, yeah. And so, just like the other one, this is an array of students. This is an array of groups. So I'm going to need two indices. So I'm going to need another index. Let's make it J. I'm going to need a J. So J is going to be I is going to be my index into students. J is going to be my index into groups. Now groups is initially empty, so J is initially 0. Or this is the number of elements. This is the number of groups. Oops. Let me call this n, by the way. Okay, I'm going to need another one. Can I number? Can I? No, I don't want to call. I'm going to call this. This is the number of groups. I'm going to need a j as well. All right, so I need an n. All right, so I'm gonna, in order for me to do this, I'm gonna need one variable that indexes into here. I'll need another counter, if you'd like, which is the total number of groups I've found. Right? This one's gonna be 5. This one is gonna be 1. This one is gonna be 2. Okay. That's my n. Okay. Can this thing be totally empty? Maybe. So I'm going to use a while loop again. In fact, I'm going to use the exact same while loop. So I'll be a scoundrel. I'll just copy it. In fact, I'll need this too. All right, fine. All right. So, all right, n is going to be the total number of groups. This is the group of the particular student that I'm indexing. Somewhere I got to have an I++. All right, I did the same sort of thing. How many times through this loop am I going to go? This guy is going to go 1, 2 times. See that? This guy is going to go 1, 2 times through the loop. So yeah, let's put a breakpoint here and see if I is properly a 2 when I get down there. Again, don't write too much code until you debug, because you got to understand the parameters. Okay? I is equal to a 2. There are 2 elements in it. I run it again. What's I going to be? What's going to be I for this one? Not the number of groups, but I is the number of students. 1, 2, 3, 4, 5. I is equal to 5. Let's do it one more time. How many guys here? Whatever, 17, some large number. All right? Run. 19, that's what's the number, okay? So now I am comfortable that I can access all 19 of my guys, and now I'm going to look for groups, okay? So, all right? And so, this is initially empty but we can look at it. Fine, let's look at it. This will be very fun to do. You see it there? Can somebody read the address of it? Let me go over here and you can see it here. See right there? 62C. You with me? 62C. What is its type? Unsigned. So you can open another memory window. You got a bunch of them. Yeah. Okay. Let's open another one. 0x2 1 2 3 4. Okay. 62C. Was that it? 62C. All right. What type is it? They're 32-bit guys, so I gotta make it 32-bit guys. They're unsigned long, and let's make them decimal. Okay. And you can see I populated it with crap, just so that you can see it happening. Okay. So there's my array of groups that I haven't written to yet, but I will. Okay? So what is my strategy for adding a new group? What's my strategy? The strategy is I'm going to look and see if 33 is already in. As a matter of fact, let's right here, first time through, that's going to be a 33. So what I'm going to do is I'm going to look for j equals 0, j less than n j plus plus. What did I just search over? What was n? N was the number of groups I've seen so far. J is a free variable I haven't used yet. What is in there? Those are the groups I have so far. And so right in here, I'll look and see is if group, okay, is equal to groups bracket J, what does this mean? What does this mean? It's already there. All right? So I'll go already there equals 1. All right, so now I got already there, so already spell it right. Or not, I don't care. All right? And so I'm going to initialize right here. Okay, so I search for what does it mean if I get to here. If I search through all the existing groups and already there is still equal to 0, what does that mean? It's a new one. So where do I put it? I put it into groups. Where do I put it? I put it at n, because that's the size. What do I put there? I put the group guy there. I put the G there. Okay? And now I got one more of these. Could be done. I don't know what else do I got to do. So I'm only incrementing n if I find a new one. Okay? So let's look at the first test case and let me step through it. Right? The first test case is I got 2 students in different groups. Right? So am I expecting to find it? No. Okay? So build. Breakpoints, run to the first one. I missed it. Oh yeah, there. I got too many breakpoints. That's good enough. All right. Look at my watch window. Count doesn't mean anything anymore. Already there. Let's add already there. Let's see. Let's add n. Let's add n there. Let's add j there. Again, if these were local variables, you actually wouldn't be able to see it. Let's get rid of this one because I'm done with that one. Let's get rid of that one. All right, let rid of that one. All right. Okay. So how many total students are there? 2. So I should go from 0 to 1. Okay. What is the group name of the first guy? What is the group? Oh, put it there. Come on. G. Yeah, enter. Okay. The first guy is group 33. You see him right there? Okay. When I step through this next crap, what's the for loop going to do? It's not going to execute at all because n is still 0. Right? So it doesn't execute at all. Already there is still 0. And so it's going to store the 33 into the group name. Look at. There it is. Oops, missed it by 1. Hold on. So 630 is where it is. 630. It moved because I added local variables. You see that? 630 is where it went. I added global variables, so this guy moved. There it is. 33 right there. When I go through the second time, right, I is equal to 1. The group value, the group guy here, is now 123. And now it's going to search, and it won't find it there. And so it'll add the 123, and you'll see the 123 showed up right there. and it's going to return a 2. Okay, let me run to the second one. Okay, this is the second case. Okay, where I'm going to look for, and I'm going to watch 123, 555, 42. This I'm going to watch them populate in here as I execute this. Say there's the 111. Put a breakpoint. What happened? Anyway, I'm done. Okay, you're kind of crashed. All right, cool. I crashed. Okay, stop. Oh, the breakpoint's there still. So. 100. All right. Okay, so general questions. Yeah, question.
On the handout for this, it shows the group ID 43 being in here. Is that a
Okay. Yeah, now we are often categorically, we change it and we don't update the thing. That's a typo. So I knew there was a typo in this one, so I triple checked your test on Tuesday doesn't have any typos that I know of. But what he noticed was the exam sheet had different test cases than the grader. So Yarabali printed the exam, Valvano changed the test cases, and they got out of sync. Which are the right test cases? Those are not the right. Those are similar, but not identical.
The test cases, 43 wasn't even in the test cases on here.
I know. I'm just saying that's a typo. Will there be typos on your exam? I hope not. You found a typo on that exam. Yeah. Question.
Could you scroll up to the previous question?
Yes. He said, let's look at the previous question. Question? Is that what you want me to do?
Oh, yeah, I was just
Yeah.
trying to look.
Question?
So on the exam on Thursday, are we gonna be able to see if our code passes the test cases?
Yeah. He said, how do I tell whether you pass or not? There's a little thing that says 100. Once you get 100, you raise your hand and you leave.
So we can see our score.
You will see your score. That you will see all of the example exams give you a score. Now that looks a little different. When you don't get it right, it may or may not give you a lot of information. Did I answer your question? Yeah, question.
So do we get 75 minutes or 60 minutes?
You're going to get 75 minutes and the next class starts coming. You can't have 75 minutes.
Wouldn't it be 90 minutes for the next class?
Yeah.
Because we have 90 minutes. We have to
No, you don't have 90 minutes. We have legally, okay, if you go 90 minutes, you're missing your next class.
We were okay with that.
We're let out 15 minutes earlier.
I mean, the only way for me to not get in trouble with the dean is to give you 60 minutes of programming, 5 minutes of crap to get you to download it, and 10 minutes for us to go around and look at your score. We have to run all 90 of these. So at the end, you stop typing and we go down the list and look and write on your score sheet what you got. And then you upload it. And you don't have 75 minutes to do it. So you're going to have 60 minutes of typing. Now what Yarabali did is scheduled a 2-hour slot in the evening in the spring. That's why it says 75. And then 2 hours was enough. The problem with that is when I schedule in the evening, about 25% of you will have an excuse. And then I have to give you a really hard exam if you've got an excuse. And I won't do that. Everybody gets the same exam. 60 minutes.
We're okay with the evening.
No, you can't. I can't change it at this point.
Is that for 5 questions? 60 minutes for 5 questions?
Okay, fine. Can I get 60 minutes for 100 points? He said how many questions you got. I don't know. I can't. I'm not answering that.
For the third example, so C, the return is always the first return that we give. It always prioritizes the first one it gets, so we have 2 return variables.
I don't get you. What do you mean? In C, a group average, I only got one.
There's the bottom return and there's return 0. So if it gets to that, oh.
What? I took rid of it. What are you talking about? What are you talking about, man?
There's return 0 in the if statement. Yeah.
The if return 0, and then there's.
Oh yeah. This okay, yeah, fine, whatever. Whatever. Yeah, what returns? He said, what does the C do when it hits the return? It returns.
So if it hits return, it won't return below that return.
No, the first one it executes. I still don't see what you're talking about, but oh yeah. This one, if count is equal to 0, it returns and doesn't get to that spot. That's just like in assembly language. Okay, would you like this? Would this make? I don't know if this makes more sense to you. Does this make sense to you? I don't know which makes more sense to you.
How do they calculate that?
Does this makes more sense to you? Does this make more sense to you? Okay, they're the same thing. This is a little easier to debug. You can see that. More questions. I'm going to go ahead and stop the tape. I hope. Function F10.